Good afternoon, class. We are looking at exam 2 review, chapter 3, differentiation rules. Exam 2 covers from 3.1 to 3.8. Here's the second part, section 3.4, the chain rule. First, I want to remind you of a couple of formulas. This is the power rule. The derivative of x to the power of n is nx to the power of n minus 1. Exponential rule. The derivative of the power of x is itself, e to the power of x. The derivative of sine is cosine. The derivative of cosine is negative sine. This is the product rule. Fg prime is f prime g plus g prime f. This is the quotient rule. F over g prime is f prime g minus g prime f over g squared. So we want to find the equation of a tangent line to the graph of the function y equals e to the power of x times cosine x. So first and foremost, we notice that we are given a pair, we need to find the slope. To find the slope, we have to differentiate. To differentiate, this is the product of e to the power of x and cosine x. We put it raised down in between. Then we call one of them f, one of them g. So this is the f function, this is the g function. And now we are going to follow the product. So y prime is f prime g plus g prime f. Again, f shorthand notation for f of x, g shorthand notation for g of x. So the derivative of e to the power of x is itself times g, which is cosine x, plus g prime. The derivative of cosine is negative sine x. Derivative of cosine is negative sine x times f e to the power of x. And all of this is done from memory. We factor e to the power of x out, and we get cosine minus sine. So this is the derivative function. This is y prime. This is not the slope yet. It becomes the slope when we plug in 0. So m is y prime of 0. So if I plug in 0 here, I get e to the power of 0, cosine of 0, minus sine of 0. E to the power of 0 is 1, cosine is 1, sine is 0, and the answer is 1 times 1 over 1. Because this is the y-intercept, with b being 1, we're going to use y equals mx plus b. M happened to be 1, b happened to be 1 as well. So y equals x plus 1. This is the equation of a tangent line at the pair 0, comma 1. Y equals cosine x over 1 minus sine x. We want to take the derivative of that. We notice it's a fractional format. Therefore, we have to use the quotient rule. So we're going to call the top one the f function, the bottom one the g function, f over g. So f prime g minus g prime f over g squared. Again, I'm reminding you, I'm using the shorthand notation, and the order that I put is because it's similar to the order for the product rule, and it makes it easier to memorize, in my opinion. So we need f prime. The derivative of cosine is negative sine x, times g, the denominator is 1 minus sine x, minus g prime. 1 is 0, minus is minus, sine is positive cosine x. So the derivative of the bottom is simply negative cosine x. So minus negative cosine x times the numerator, cosine x. Then you put the denominator g, 1 minus sine x, put it in a parenthesis and square that. And this, with the asterisk next to it, is the end of calculus. Everything else is algebra, trigonometry, you name it. So we distribute, we get negative sine x here. We get plus sine squared, negative times negative plus cosine squared. One of those Pythagorean identities, sine squared and cosine squared, they add up to 1. So notice what we have in the numerator. In the numerator, we have minus sine x plus 1. That means 1 minus sine x. So this one can cancel out the exponent here. And y prime becomes 1 over 1 minus sine x as the final answer. So now the chain rule. How would you differentiate composite functions? Example, y equals square root of 10x plus 5, f of x equals 10x squared minus 1 to the power of 50. That's when we use the chain rule. So what is the chain rule? If g is differentiable at x and f is differentiable at g of x, then the composite function f of g of x is differentiable at x. D dx of f of g of x is f prime of g of x times g prime of x. In other words, if you look at f of g, the composite function, f is the outer function, the shell function. So differentiate that f prime with respect to g of x. And then the inner function is g of x times g prime of x. This is by the chain rule. Or in Leibniz notation, if y is a function of u and u is a function of x, g of x, then dy dx is dy du du dx. And I hope you see dy dx. This is not a fractional format that you think these two cancel each other, but you can think of it that way. It'll help you memorize that. So if capital F of x is f of g or f of g of x, then capital F prime, the derivative of that would be f prime of g of x times g prime of x. Bear in mind, this is the shell function, the outer function, g is the inner function times g prime. So, for example, we remember that the derivative of x to the power of n is nx to the power of n minus 1. This is the power rule. Now, what about the extended power rule? If I want to differentiate g of x to the power of n instead of x to the power of n, I follow to a certain degree. For example, I need this, the exponent is n here, the exponent is n here, I need n. Over here, I say x to the power of n minus 1. X to the power of n becomes x to the power of n minus 1. G of x becomes g of x to the power of n minus 1. Finally, I want to go back here. The derivative of x, everybody, is 1. And whether you write it or not, it makes no difference. However, the derivative of g is not 1, is g prime of x. And that is what makes it the chain rule. One way to understand this better, I think if we look at the following trigonometric functions, or better yet, sinusoidal functions, if you want to differentiate sinusoidal functions, I would say just read sine and pause and say, okay, y prime sine is cosine. But you have to have an argument, and you must use the same argument. If the argument is x or t or theta, you're done, because they are independent variable and the derivative is 1. But 2x, the derivative is not 1, is 2, so times 2, and you rewrite it as follows. If you want to do it here, again, I would read sine, and then I would pause, and I say the answer is cosine. I can't write cosine without any argument. It must have the same argument. This time, by the chain rule, I need the derivative of x squared, which is 2x, and I put it in front. You make sure you put the 2x in front, otherwise it's awkward. If I want to differentiate the last one, I don't have to rewrite it, but I think if it helps, you must. I'm going to rewrite it as sine x to the power of 2 In other words, I'm here using the extended power rule. I get 2 sine x to the power of 1, and then the derivative of sine x, which is cosine x. 2 sine x, cosine x. I believe they will help us understand this concept of a chain rule better. Warm-up example, let y be u to the power of 5, which makes it a function of u, and u be 10x cubed plus 2, which makes it a function of x, g of x. And so we want to differentiate, and we are going to use both methods, Leibniz's notation as well as the composite function. So dy dx is dy du du dx, according to the formula. So dy du means take the derivative of y equals u to the power of 5 with respect to u, which is simply 5u to the power of 4. Du dx, that means take the derivative of u equals 10x cubed plus 2 with respect to x, which is 30x squared. And we're done with calculus. We're going to replace the u with 10x cubed plus 2. G of x is 30x squared. We multiply these two, we put it in front. We get the final answer 150x squared times 10x cubed plus 2 to the power of 4. So we did use the Leibniz's notation. However, finding the composite function y equals f of g or f of g of x is not difficult. We can say f of the g function is 10x cubed plus 2, which means instead of u, we are going to put 10x cubed plus 2, and y becomes 10x cubed plus 2 to the 5th power. So according to the composite function, y prime is f of g prime is f prime of g of x, g prime of x. And to differentiate this, in essence, you're using the extended power rule. 5 sits in front. 10x cubed plus 2 to the power of 5 minus 1 becomes 4. And finally, g prime of x, the derivative of the inside, which is 30x squared. And if you multiply these two, you put it in front, you get the same expression, 150x squared times 10x cubed plus 2 to the power of 4. This is known as the chain rule. So, a quick recap. We use the Leibniz's notation here. We use the composite function. Sometimes finding the composite function may be difficult, too long, and you want to go with this format or that format. So you want to understand the Leibniz's format, you want to understand the composite function, and sometimes this is easier, you want to stick with that. Y equals 10x squared minus 1 to the power of 50. We use the extended power rule. So you write the formulas. If I'm differentiating this, I'm going to write this formula from the memory, and I'm going to follow that. Instead of writing ddx of this and ddx of that, so I'm going to write n, which is 50. Then the same thing to the power of 50 minus 1 of 49, g of x to the power n minus 1. Then the derivative of the inside is simply 20x. And I multiply these two, I get 1000x, I put it in front, and I'm done. Y equals square root of 10x plus 5. To take the derivative of that, we write it in a format such that power rule or extended power rule can be used. So we're going to rewrite this as 10x plus 5 to the power of 1/2. And now you just follow that. Y prime is n, which is 1/2. G of x to the power of n minus 1, 10x plus 5 to the power of 1/2 minus 1 is negative 1/2. And finally, g prime, the derivative of the inside is simply 10. Again, done with calculus. I hope you recognize 10 and 1/2 puts the 5 In the numerator, this is negative 1/2 goes down, becomes positive 1/2 and its square root. So the final answer is 5, 10 and 1/2. The product is 5. This goes down, becomes square root of 10x plus 5. Y equals 5 times 3x minus 2 to the power of 4. So what is y prime? The 5 is a multiplier remains. Now we treat this using the extended power rule. So 4, same thing to the power of 4 minus 1 or 3. Finally, g prime, the derivative of the parentheses inside the parentheses. The derivative of 3x minus 2 is simply 3. The product of 5 and 4 and 3 is 60. We put it in front and we are done. Exponential functions. The derivative of e to the power of x is e to the power of x. Composite function, the derivative of f of g of x is f prime of g of x times g prime of x. So if we happen to have e to the power of g of x, exponential is itself, by the chain rule times the derivative of the exponent, which is the g prime. If you go back here, the derivative of the exponent x is 1, you don't have to write. So if it happened to be e to the power of kx, it's e to the power of kx, the derivative of the exponent is k, so you put the k in front. So anytime I have an exponential, the first thing I do, and you don't have to do it in 2 shots, I like to do it in 2 shots to make a point. I'm going to immediately write the function itself. E to the power of 10x, the answer is e to the power of 10x. Then I look at the exponent, and its derivative is 10 times 10, and I put it in front. Again, you don't have to do it in 2 shots. Okay, 1 shot is fine. Just want to make sure we understand that. This one, I'm going to do the same thing. I'm going to say the answer is itself. So just write the same function. I look at the exponent, t squared. Its derivative is 2t, and I put that in front. E to the power of t to the power of 2. First, I'm going to rewrite it as e to the power of 2t. It makes it easier to deal with. Then I'm going to write y prime is itself times what? The derivative of 2t. 2. I put it in front. We are done. Y equals e to the power of 2x over 3. Not that you have to, but I am going to change this to 2/3 x so it becomes clear x has a coefficient. And if I want y prime, the answer is itself. Now times the derivative of 2/3 x, which is 2/3. And I'm going to put the 2/3 in front. And I'm done. Y equals 5x times 3x minus 2 to the power of. First, I want to explain about number 5 in front. This is going to carry over in every step. So you have a choice. You can take it as part of x and say 5x times this, or put this in brackets and just work on this and carry the 5. Now, I'm going to treat this as the following. This is the f function. This is the g function, and go with the product. Why is that? Because 5 is a small number, not a big deal. If instead of 5, I have 5,000, if I have a big number, or if I have 1/5 or 0.589, then I would do that because otherwise it becomes crazy to keep it as part of X. So now f prime g, and I'm going to go with the product rule first, and then I need the extended power rule or the chain. This one gives me 5. F prime is 5 times g, 3x minus 2 to the power 4, plus g prime. Now, the derivative of this guy requires the extended power rule, which is 4 plus 4 times 3x minus 2 to the power of n minus 1, 3x minus 2 cubed times g prime. The derivative of the inside is just 3. And then I go to the product rule, back to the product rule times f times 5x. In other words, we have f prime g plus g prime f. And I'm going to put an asterisk next to it, meaning I'm done with calculus. Now I need a couple of steps of algebra to finish the job. And so to make sure we understand what's going on, I'm going to say, okay, this is itself 4, 3, and 5. It's 60, so 60x. So I'm going to write it so it becomes easier to see the common factor, which is 5, between 5 and 60. You have 3x minus 2 here and here. This is the exponent 4, this is the exponent 3. You choose the smaller of the two, so 5, 3x minus 2 cubed is the common factor. I hope everybody's comfortable with factoring. So if you divide this one by this one, it just gives you 3x minus 2. If you divide this one by this one, this goes away. 60x divided by 5 gives you 12x. 12 and 3 add up to 15x. So the final answer is y prime is 5 times 3x minus 2 cubed times 15x minus 2. So we're done. I want to show you if we go this route and differentiate. So first, you're going to write y prime is 5, and then this is f, this is g. In other words, f is just x, not 5x. So 5, and then the f prime g plus g prime f. F prime is 1 times g, 3x minus 2 to the power 4, plus g prime. G prime, we already did that. Remember that the derivative of this piece was this piece. And then times 5x instead times just x. So please understand this part. You have the same thing here. Instead of 5x, just x, right? And so this 5 carries. And of course, I'm not going to finish it, but you end up with the same answer. My point being, you can keep this number out, and you must if it's involved. In this case, it really doesn't make much of a difference. Y equals x squared plus 4x over x to the power of 6. The first question we ask, okay, this is probably extended power rule. Do we have to use in conjunction with the quotient rule? The answer is no. If you have to use the quotient rule and you don't use it, you're making a mistake. If you don't have to, then it's the same thing. Okay. This gives you x, this gives you 4, and if you don't see the easy way out, the long way will not cut it. Now we go with the extended power rule, and we say 6 times x plus 4 to the power of 5, and then g prime. The derivative of x plus 4 is 1, but I like to write it because I want to emphasize that I need g prime of x happen to be 1. And the answer is 6 times x plus 4 over 5, and we're done. Y equals to x squared plus 9x plus 9 over x plus 3. You may have to use the quotient rule, or you may not. When is it that you don't need a quotient rule if you can simplify? If you can simplify, that's the key word. So if we can factor this, because this is 2, it has to be x, and it has to be 2. Now, let's say you can factor it, and it doesn't have a factor of x plus 3. Then it doesn't simplify, then it doesn't do you any good. So put a plus 3 and see if it works, and it does. Then you need a 3 here, these two 6x, these two 3x, they add up to 9x. So try to simplify, and it might work. And now, of course, the answer is simply 2. You don't have to work hard. So my point being, always look for algebraic technique to simplify the expression if possible. What about 2x plus 3 over x minus 8? First, we are going to use the extended power rule. 5, okay, n is 5. Then g of x to the power of n minus 1. The expression, whatever it is, to the power of 5 minus 1, namely 4. And now g prime, the derivative of the inside requires the quotient rule. So we are going to call this one f over g. And for this fraction, we're going to use that. That is chain rule with the quotient rule. So f prime g minus g prime f over g squared. So f prime is 2 times x minus 8 minus g prime is just 1. So minus 1 times the top is 2x plus 3 over the bottom, x minus 8 quantity squared. This is it. As far as calculus is concerned, everybody, you're done. Now you do a few more steps to simplify, all of which are algebraic steps. So we start with this. We write 2x minus 16 minus 2x minus 3. 2x and minus 2x cancel each other. These two add up to negative 90. So we have a 5, 2x plus 3 over x minus 8 to the power of 4, negative 19 over x minus 8 squared. So what I want to do, I'm going to keep this one, I'm going to keep this one. I'm going to write this one, 2x plus 3 to the power of 4 over x minus 8 to the power of 4. I do that so it becomes clear that exponent 4 is part of the numerator as well as the denominator. So when I want to put them together, for the top, I get 5 times negative 19, which is negative 95, times 2x plus 3 to the power of 4. For the bottom, I get x minus 8 to the power of 4 plus 2. 4 plus 2. So I get 6. Now, if right here, you recognize this has exponent 4 and 2, 6, so be it. You don't have to go this route. But I want to make a point, and that is understanding how to simplify this into this fraction. All right. What about y equals 4 over square root of x squared plus 3? To differentiate this, we have to put it in a format which is doable. Okay. So first and foremost, square root of x is x to the power of 1/2. So we put this one to the power of 1/2, x squared plus 3 to the power of 1/2, and we bring it up to the power of negative 1/2. And this way, it's ready for differentiation using the extended power rule. So we're going to stick with that. N, so 4, first 4. Then n is negative 1/2. Then the same thing to the power of n minus 1. This thing to the power of negative 1/2 minus 1, which is negative 3/2. And finally, g prime, the derivative of the inside, which is 2x. Now, all you have to do is simplify this expression. Again, this is the only calculus step, everybody. And to simplify this again, I'm going to say this is negative 2 with this one becomes negative 4x. So I combine them so it becomes clear. This guy has an exponent which is negative, goes down and takes the exponent which is positive 3/2 using negative exponential rules. So positive 3/2. And positive 3/2 means square root of x squared plus 3 cubed. So we put it in the format that we received it. Now, what about y equals cosine 3t to the power 4? As I mentioned, anytime you're dealing with a trigonometric function, just look at cosine and pause. You know that the derivative of cosine is negative sine. And of course, you can't write it without its argument. So you must use the same argument. And now, by the chain rule, cosine u requires du dx. In this case, it requires du dt. So you're going to differentiate this with respect to t, giving you 12t cubed. And you put that in front. The final answer would be negative 12t cubed sine of 3t to the power of 4. All right, we want to differentiate y equals e to the power of tan x. And again, reminding everybody the derivative of e to the power of x is itself. The derivative of e to the power of kx is itself times k because the derivative of kx is that. And the derivative of e to the power of g of x is itself times g prime. So having said that, the derivative of e to the power of tan x, just write it itself. And then according to the chain rule, the derivative of the exponent, the derivative of the exponent, the derivative of tan x is secant squared x, and you're done. And there's really not much you can do at this point. What about y equals 3 to the power of x? Notice what we've been dealing with here, the base was e. And so the problem is the base is not e. So we are going to use our technique of logs and logarithmic properties. So we take it back to the base e so we know how to deal with it. So reminding everyone that when we have y equals b to the power of x, and ln of e to the power of x is x, e to the power of ln x is x, I can rewrite the base b as e to the power of ln b. B is the same as e to the power of ln b. Let's replace that. And so e to the power of ln b to the power of x means e to the power of ln b times x. And the reason we put it in this format, now that we have the base e, we are going to follow the instruction. If I want to differentiate this, I just follow the instruction here, or here in this case. So the derivative is itself times ln b, because this one, the derivative is itself times k. And bear in mind, ln b is a number. And so we are done, except, we know e to the power of ln b is b, so I'm going to replace it back and I get b to the power of x, meaning if you have a different base, the answer is itself. And then times ln b times ln 3. In other words, 3 to the power of x times ln 3, and you just rewrite it. You want to keep 3 to the power of x in front, because if you put it in the back, one may read it as ln of 33 to the power of x. You don't want that mistake. What about this one? We are, in essence, getting into the chain rule as well. If y is b to the power of f of x, the derivative is itself, times by the exponential rule, times ln b by the logarithmic properties, times f prime by the chain rule. So the answer is itself. The base is e, no, times ln 5 times ln 5 by the logarithmic properties. Is the exponent x? No. There the x squared, so we need g prime by the, or in this case f prime by the chain rule. There the x squared, the derivative is 60x. And we put them together in the following manner. 60x ln 5, we put them together in a parenthesis. They are being multiplied by 5 to the power of their dx squared. What about f of x being x to the power of 4, e to the power of 2x? You want to differentiate that. You notice is the product of two things, therefore you put a raised dot in between, and let's say this is the f function, this is the g function, and therefore we are going to go with the product rule. F prime g plus g prime f. F prime is 4x cubed times g, which is e to the power of 2x, plus g prime. Now, what is the derivative of exponential? Itself. Then you look at the base is e, so we are fine. You look at the exponent is 2x, so we need by the chain rule times 2. And then g prime f, x to the power of 4. And this is the extent of calculus. We are done. We are going to simplify by factoring the common factor. So what is in common? Between these two, 4 and 2, 2 is in common. Between x cubed and x to the power of 4, x cubed is in common, and e to the power of 2x is identical. That is also in common. If you divide this piece by this piece, it just gives you 2, everybody. And if you divide this piece by this piece, it just gives you x. So we get 2x cubed e to the power of 2x. This gives us 2. This gives us x times the parentheses 2 plus x. That is the final answer. We want to differentiate this again. 9 is not a huge number. You can think of it as part of x. Therefore, you put a raised dot in between, and we are looking at f times g. And so we're going to go with the product rule, f prime g plus g prime f. F prime is 9 times g, which is x minus 1 to the power of 4. plus g prime. We use the extended power rule on that, for g of x to the power of n minus 1, x minus 1 cubed times the derivative of the inside happened to be 1, and then go back to the product rule times f 9x. And this is the end of the story as far as calculus is concerned. We are going to simplify by taking the common factor. We notice between these two statements, 9 is in common, x minus 1 is in common, exponent 4 versus exponent 3. You go with the smaller of the two, exponent 3, therefore 9 times x minus 1 cubed is taken out as a common factor. And so if you divide this one by this one, gives you x minus 1. And if you divide this one by this one, it gives you 4x. The brackets, you can add up x and 4x to get 5x. The final answer becomes 9 times x minus 1 cubed times 5x minus 1. That is p prime of x. Now, cosine to the power of 10 of sine x cubed. First, I want to make sure we understand this means what. So I'm going to rewrite it as cosine to the power of 10. So cosine of the same argument, namely sine of x cubed to the power of 10. Just to make it, I think, a tad easier, instead of sine x cubed, we choose some function for that. We call that f of x. And then we want to work on that. So cosine of some function to the power of 10. So we're going to follow that, and then we work on f of x, which is sine x cubed. I think it makes it a tad easier. So you are looking at this one, everybody. You want to differentiate this. So we are going to go with the extended power rule. So n, which is 10, then g of x to the power of n minus 1. That means cosine, whatever is in the brackets, cosine of f of x to the power of 10 minus 1, meaning to the power of 9. And you can write cosine to the power of 9 f of x. This is the proper notation as well. And then, so we got the n, we got g of x to the power of n minus 1. Finally, we want g prime. So what we want is the derivative of the brackets, the derivative of cosine of f of x. The derivative of cosine is negative sign. And remember, if it's x, you're done, but it's f of x, therefore you need f prime of x. Okay, now I'm going to write it here so everybody be clear. If you're looking at cosine f of x and you want to differentiate, you say cosine and you stop. Cosine results in negative sign. You need the same argument. And if it's x, you're done, because it's not, you also need f prime of x. That's what this is all about. And we are going to continue in a moment. Now, let me erase my board. So 10, cosine to the power of 9. F of x is sine of x cubed. Brackets minus sine. F of x is sine of x cubed. But what is f prime of x? Let me also write this on the side and work on it, because I want to make sure we understand. F of x is sine x cubed, and I'm going to again say sine. So f prime is sine becomes cosine. Cosine of what? The same thing. Is this x? No. You need the derivative of that. So for this part, so we have 10 cosine to the power of 9 sine x cubed minus sine of sine x cubed. For f prime, we are going to write this cosine of x cubed times 3x squared. Cosine of x cubed times 3x squared. Let me erase my work. Now you put them all together. You have 10, you have negative sign, you have 3, so you get negative 30x squared in the beginning, cosine x cubed, and the rest of them. So negative 30x squared, again 10, negative sign, and 3x squared, negative 30x squared, cosine of x cubed, cosine to the power of 9 of sine of x cubed, and sine of sine x cubed. That's what we get as the final answer, everybody.